is lesson 8, the Pythagorean Theorem, and we're going to take also a look at some of our PAT practice questions before the final exam. So we have final unit exam is what I'm talking about. The Pythagorean Theorem. So according to the Pythagorean Theorem, the sum of the areas of the two red squares, A and B, if you add them up, the areas of those, that's going to equal to the area of box C, the blue square. So let's put some digits in there and see how that works. So if I've got B, if I take B as a 5 by 5 square, that means his area would be 25. If I take A is a 12 by 12 square, that means the area would be 144. Now, if I take those areas and I add them together, that's going to give me an area of 169 over here. If I square root that, I'm going to get my side lengths. I square root that, and it's going to give me 13. So that means that a 5 squared plus 12 squared is going to give me 13 squared. Okay? Let's see how this actually works. You've been working on this for a couple years. This is just a review. So, the Pythagorean Theorem states that for any right triangle, and it only works for right triangles where you've got a 90-degree box in one of the corners. So whenever you see this little box, that means it's a 90-degree triangle. So it says, again, we've got our A for altitude, the height, and B for base. So anytime our A squared plus B squared equals C squared, that means that we have a short side squared plus a short side squared is going to give me my long side squared. Okay? So whenever I'm adding, I'm finding a long side. Now, we're not always finding a long side. What if I need to find one of the short sides? Does it matter which one I need to find? No, I just need to be able to do inverse operations. So what I'm going to do is I'm going to change my Pythagorean theorem to solve for A or B. So this is how it would look. If I need to solve for A or B, I'm going to solve for A. That means I need to take B to the other side. Right now, B is a positive, so to move it to the other side, it becomes a negative. So that means that A squared will be equal to C squared subtract B squared. Now, how do you know who subtracts who? Well, it was the B who moved over, so he's the one you subtract. It's always the C side, which is your longest side, subtracting a short side. So this is if you want to solve, that equation, pardon me, is if you want to solve for a short side. So that's if we want to find a short side. And your short sides are called your legs. And your legs are always attached to the 90-degree angle. So there's one leg, and the other leg is also attached to your 90-degree angle. That's how I know who are the short sides and who the legs are. They're always attached to this 90-degree angle box. The longest side is across from that 90-degree angle. So this is always the longest side on any right triangle. We call that now the hypotenuse. The longest side is now called our hypotenuse, where A and B are also called legs. Okay, so they are each legs. A and B are legs. Okay, let's do a couple examples and see how it works. Let's see what you remember from last year. So if I take a look at this first example, am I finding a long side or short side? Well, this is short, this is short, this is long, I'm finding a long side. So that means I'm going to be adding. So I'm going to take 3 squared plus 5 squared to give me x squared. I'm going to solve each separately because I can't use my exponent laws here because our bases are different and we're not multiplying or dividing. So I'm going to solve each separately. That's going to give me 9 plus 25. When I take 9 plus 25, that's going to give me 34. That's all equal to x squared. Now, how do I find x by itself, not x squared? I take the square root of those. The square root of x squared, opposite functions cancel, so my root sign disappeared, my squared sign also disappears, so I get x equaling the square root of 34. Now, it says to round to a tenth, so the square root of 34 is going to give me 5.8 when I round it. Okay? That's what I get for my first example. Let's look at a couple more examples. On my next example here on the left-hand side, the yellow triangle, again, which kind of side am I solving for? I need to find my long side. So since I'm finding my long side, I'm going to take my other sides and add them. So I'm going to get 11 squared, I can't add them until I square them though, plus 8 squared. And that's going to give me my x squared. So now 11 squared gives me 121, and 8 squared gives me 64. And that's all equal to my x squared. I'm going to add those together, and that's going to give me 185. So 185 is equal to my x squared. Now I need to take the square root of 185, and that's going to give me x. So take your square root of 185, and again, round to 1 decimal place. We should get 13.6. Okay, let's take a look at the other triangle. When I look at the blue triangle here, blue or green, whichever shade you see, I'm going to notice I'm finding a short side because there's my long side, and my long side has a number on it. So whenever your long side has a number, that means you subtract from the long side. So that means I'm going to take 1.3 squared and subtract one of the short legs, 1.2 squared. Okay, I'm not adding this time, I'm subtracting because I'm finding a short side. Okay, and that's going to give me my x squared. So let's solve each of those. I'm going to get 1.69, and I'm going to get 1.44. And again, that equals our x squared. So I subtract both those decimal numbers, I get 0.25. That equals our x squared. Again, my last step, just like on the previous question, your last step is always square rooting to get rid of your x squared. So now I'm going to square root 0.25, and that's going to give me x. When you do that, you're going to get an exact decimal. It's not a run-on decimal, an exact decimal of 0.5. So now I know that x equals 0.5. Let's look at a couple PAT example questions. Before we do that, in your homework, you can take a look at a few questions in your textbook. So you're going to take a look at page 19, and you can do question 13. Okay, a couple PAT questions to look at here. So the first one says, how many of the square roots shown above have a value that is between 7.8 and 8.8? Well, we don't know. So what we're going to have to do is we convert all of them to decimal form. How do I do that? I actually use the square root function on my calculator. So I'm going to take the square root of 51. So if I take square root 51, I'm going to get 7.1414, and it runs on forever. The next number, root 55, I solve that, and I'm going to get 7.416, etc. It runs on forever. The next question, or the next number, is root 61. I solve him, and I'm going to get 7.8102, and so on. It runs on. Then I take the next number, root 66. The square root of 66 is 8.124, and so on. It runs on. And I keep going. So I've taken care of all those numbers. Now I got the last 4 digits to deal with. So the last 4, we do the exact same thing too. So I'm going to take the square root of 71, and that's going to give me 8.426, and so on. Then I take the root of root 77, and that's going to give me 8.7749, and it runs on. Then I take root 81, it's exactly 9, and I take the root of 88, and it's 9.308, and so on. So now the question is asking us, how many of those numbers are between 7.8 and 8.8? So now I can take a look at them, and I can highlight which ones are bigger. So root 61 is bigger, or I should say it's between 7.8 and 8.8. So is root 66, and so is root 71. And so is root 77. Root 81 is larger, and root 88 is too large. So I found 4 numbers that are between 7.8 and 8.8. Okay, that's how you solve that question. Taking a look at the next question, we need to use our exponent laws to solve this. So first of all, I've got an exponent on the outside of brackets. I know that's telling me to times them. So the first thing I've got is x exponent 6. Then I write the rest of the equation down, so I'm not done solving. Divide by x exponent 4. But when I'm dividing, and the bases are the same, and yes, I have x's, I need to take my exponents, and now I can subtract them. That's going to give me a result of x exponent 2. All right, that's the left-hand side of my equation here. They're telling me that that all is equal to 144. So the equation I have now simplified on the left-hand side is x squared. The right-hand side says 44. So what number is going to give me 144? What number squared? Again, you do opposite function. I need to square root those in order to solve for x. They cancel, I get x is equal to 12. Okay, so the whole number value of x, we found the answer is 12. All right, let's move on to the next couple questions that you tried. 14, again we need to use our exponent laws. It says we want to add 7 squared and 7 cubed. Well, we cannot use our exponent laws when we add. So what I need to do is I need to see how they're written in repeated multiplication. So that means I've got 7 squared plus 7 cubed. When I expand these, that's going to give me 7 times 7 times 7 plus this guy gives me 7 times 7 times 7. Oops, on the left I only have 2 of them. Okay, so now I count them all together and I get 5 of them in the end, but I only have 2 here and 2 here. They have to be grouped together. How come? Because there's a plus sign in between, and we need to solve with BEDMAS at this point. So, which one matches? Letter C matches. Okay, let's take a look at the bottom. The bottom question number 20. Question 20 is talking about, again, we've got a ton of exponent laws. So we're going to take this first section and solve it. I have an outside exponent, so that means he has to multiply to the inside. So I take 3 times 4 to get 12, so I end up with n12. Now dividing by, my n2 on the bottom comes down. In that situation, I'm dividing, so that means I can subtract my exponents. That's going to give me n exponent 10. Now, this is all beside this big bracket. So now I've got n to the 10. Divide by n to the 5 times n to the 2. So in the blue bracket there, I need to take it piece by piece, left to right. So I'm going to take this part first. Well, dividing means I'm going to take those digits and subtract them. So now it's going to result as n to the 10 comes down. I haven't used him at all yet. In the brackets, I have solved the first part here, and that's going to give me n exponent 5, because 10 subtract 5 is 5. And then I bring this n squared on the end. So timesing by the n squared. Again, with BEDMAS, I have to solve in brackets first. So I'm going to solve that part. And because I'm multiplying and the bases are the same, I'm going to add the exponents. So my green n10 still comes down. And now I get in my bracket, it simplifies to n exponent 7. As a result, now I'm going to take a look, and again, when they're written side by side, they mean multiply. I have the same basis, so I can add the exponents. That's the rule. So now that results in n exponent 17. So let's take a look at the top. Which one we have the value of p has to be 17. How come? Because it's saying my answer is going to be n exponent letter p. And they want us to know what that letter p is. Well, letter p is the exponent I'm trying to find. And the exponent I found is 17. Okay, let's move on to the last couple questions. I take a look at the top one. I need to solve each of those, and then I need to put them in the correct order or find which one has the correct order. This one wants the order of increasing value. So that means it wants it to go from small to big. Well, let's solve each of them and see who gets small to big. If I solve negative 2 exponent 4, that's going to give me a negative 4. When I solve negative 1 squared, it's got a floater negative, I get -1. The next one, the negative's in brackets, and I've got an even digit as my exponent, so that means I've got -1 times -1. Negative times a negative is a positive, so that's going to give me a +1 answer. -2 squared is going to give me -2 times -2, which is going to give me a +4 answer. So far, that is in order. I have -4, -1, 1, and then 4. On a number line, those are in order from small to big. So far, I've found my answer so far as A. Let's see if any of the other answers work out. Now, remember, it's a multiple choice question. There can only be one answer. So far, we found the answer to be A. Let's prove that B, C, and D are not correct. So when I do letter B, it's going to solve to 4, 1, -1, -4. That's going from big to small. So that's not the order I want. If I take a look at letter C is all mixed up. It puts the 1s first. I've got -1, 1. Then it puts the 4s. -4, 4. Nope, that's not in the right order either. They're all mixed up. So let's take a look at letter D. Letter D is going to give me 1, -1, -4, 4. And again, the letters are all mixed up, so my answer can't be D either. So it's not C, it's not D, it's not B. We were right the first time. Letter A was our correct solution. Let's look at the very bottom question. It's a BEDMAS question, and it's got 4 different students here, student 1, 2, 3, and 4, and they've all solved it with an answer. We need to find out which student solved it correctly. So we have to solve this one ourselves first. Okay, so let's solve that together. In this step, the first thing I need to do is brackets, according to BEDMAS. I'm going to deal with some brackets. So what does that actually mean? That means I just write the rest of the equation and the rest of the equation. Okay? So they just come down looking exactly like they started. So I've got 4 plus 3 times 5 minus 6 exponent 4, divide by, now I'm solving inside my bracket. So I'm going to solve that part. It's going to be cubed times 2. So when I solve inside these brackets here, 4 plus 2 gives me a 6. Then I take a look and I've got exponents. Because remember, BEDMAS is this. Brackets, exponents, division, multiplication. These go in order from left to right. And then I've got addition and subtraction. And they also go in order from left to right. So I've taken care of brackets. Now I'm looking for exponents. I do have a couple exponents, so I need to solve these exponents first. Again, what do? We write down the rest of the equation as it stands. So I have 4 plus 3 times 5 minus, I do 6 exponent 4 in my calculator. That's going to give me 1,296 divided by, I solve 6 exponent 3 in my calculator. I get 216. And then this times 2 comes on the end. Okay? So I've solved my exponents. So exponents are now done. Now I find multiplication and division. I do it left to right. So multiplication and division is what I'm looking for. I've got a multiplication and I've got a division. So let's do it step by step. This is going to give me 4 plus. I solve my multiplication to get 15. Subtract. I'm going to solve my division. When I divide those, I'm going to get 6 as an answer. And then I've got my times 2 on the end. Okay, so there's my minus 6. The minus sign comes down. And then I bring this times 2 part on the end. All right, I still have some multiplication. So my very next step is going to be to solve this part. I need to do the multiplying. And again, everything else just comes down. So I've got 4 plus 15. Now I multiply negative 6 times 2, and that's going to give me a negative 12. Now I'm left with addition and subtraction. So now I just do all of this left to right in my calculator. That's going to give me an answer of 7. So let's take a look. Which student solved it correctly? Student 2 solved it correctly. Check your work and make sure you did it right. This concludes lesson 1.8 and the full complete unit of unit 1 powers and roots.